So as you can see here, finding the radius of convergence and the interval of convergence of series, well, the steps are pretty systematic. Starting with the ratio test, find the interval, and then check the endpoint. Very often you will see one question on paper 3 that would ask you for the radius of convergence or the interval of convergence. And these are some of the easy mark that you can get on your IB exam. So moving on to the last one. If I have a series, infinite series, and I want to check for the radius of convergence and the interval of convergence, like what we've been doing, ratio test. Find the ratio, take the limit as n tends to infinity, and go from there. So for the first one, the n plus 1 term, I will have this one and then divide it by the second term, and we will have the absolute value for the entire thing. So absolute value, n plus 1 term divided by the nth term. The first part, negative 3 to the power of n plus 1 times it by x to the power of n plus 1 divided by the square root of n plus 1 plus 1. Then you will end up with n plus 2. And this divided by the nth term, which involves negative 3 to the n times x to the n divided by the square root of n plus 1. Like if you are weak in algebra, you can always take a step or two just to simplify these expressions here. So I can go one step further and turn the division here to a multiplication. And this becomes square root of n plus 1 at the top, and negative 3 to the power of n times it by x to the n. Time for some cancellation. This and that look similar, and in fact, the numerator here will give us a negative 3 for the extra term. Similarly, for the x to the n plus 1 and x to the n, the numerator will give us an extra x term after you reduce it. The square root n plus 1, square root n plus 2, they will still be part of your expressions at the end. So you will have the square root of n plus 1 and n plus 2. With n always a positive number from 0 to infinity, taking the absolute will only involve the negative 3x. And when you take the absolute value of negative 3x, you are just dealing with 3x and the square root of n plus 1, n plus 2. So the limit of this, using the L'Hopital's rule, this becomes a 1. So taking the limit, I'll start here. Taking the limit as n tends to infinity for this ratio test will give us just absolute of 3x. This is after the L'Hopital's rule. Make sure you state it on your IB exam. This actually worth 1 mark for the method. Like this is 1 mark for the method. If you state the method, then that's 1 mark. If you don't state it, very likely they will not award the 1 mark to you. So for this series to converge, I want the limit of this to be less than 1. And as you can see here, we are having a power series. Center at 0 with radius equals 1/3. And this is after you divide the 3 to the other side. So with absolute value of x less than 1/3 for the radius of convergence, the interval of convergence will be anywhere between negative 1/3 to positive 1/3. Center at 0. Once again, don't forget to check for the endpoint. When x equals negative 3, substitute this number into the series. This is where you substitute your -1/3 into. So now, this infinite series, let me just simplify the work here. You can probably try it on your side. But after I simplify it, we will end up with 1 over square root of n plus 1. Once again, try it on your own. Substitute -1/3 into the series and simplify it. And now, as you have n equals 0 up to infinity, this is comparable to a p-series where p equals 1/2. Or if you don't see this as a p-series, you can actually rewrite this as a series, infinite series that start from n equals 1, and I can rearrange the expressions in the radical to just n. Like I don't have to start with n equals 1 if I have n plus 1. I can also start with n equals 1 with just n in the denominator. And here, this is a p-series with 1/2 in the exponent. And from the previous chapter, we know this is a p-series with your exponent less than 1. Therefore, this is a divergent series by the comparison test. Divergence by the comparison test. So -1/3 doesn't work for the interval. We will now try positive 1/3. And once again, substitute positive 1/3 into this series. You should have your series simplify to -1 to the power of n over square root of n plus 1. And here, compared to what we have done, you can turn this into an expressions that look like this. And this time with n equals 1, I can probably turn my exponent to n minus 1. So that I'm still starting with n equals 0 for my first term. For my first term, when n equals 1, this exponent will still be 0. But looking at this, we have an alternating series. An alternating series will be convergent, even if it is a p-series with p less than 1, because I can check that this is a decreasing series. The value will be decreasing, and at the same time, your term will approach to 0 as n tends to infinity. So by the alternating series test, you are getting a convergent series at x equals 1/3. So altogether, your interval of convergence will be from -1/3 to positive 1/3, including the positive 1/3, with your center equals 0, and the radius of your convergence is 1/3. So hope that you understand the lesson. The whole thing is all about using the ratio test, find the limit, take the limit, and when the limit is less than 1, we will have our radius of convergence. And then you go from there, solve for x, find the center, find the radius, find the interval, and that's all about it. So here I have the worksheet for today's lesson. Make sure you give them a try. It is actually on the website. So give them a try. If you have questions, make sure you come and see me. Otherwise, next class on Friday, we will be doing lesson number 2.